Hi, and welcome to a video where I would like to introduce two important measures for measuring the association between two categorical variables. Those two measures are called the difference and the ratio of proportions. We use them all the time when we compare two proportions on a categorical, or more precisely, binary variable. Now, and I'm sure you have seen them before in the news or have used them on your own survey or experimental data. Let me actually show you one such data set coming from an experiment, in particular a clinical trial, a very recent clinical trial on the effect of a treatment against COVID-19 symptoms. Now, I'm taking this out of the book in chapter 3, which is all about exploring relationships between two variables. And if you go to section 3.1, in example 4, this is an example about a clinical trial on the effectiveness of a COVID treatment. In particular, there were 222 patients, as you see in this contingency table on the left, 222 patients randomized to a drug treatment. The drug was called remdesivir, and 199 patients randomized to a placebo treatment. And for every patient, it was recorded, did or did they not recover from COVID-19 symptoms after 28 days. So yes, if they did recover, no, if they unfortunately did not recover. So we have two categorical variables, which treatment the patient was randomized to, either remdesivir or placebo, so a binary categorical variable here, and a second categorical variable, whether or not the patient recovered. And because each of those two categorical variables is binary, we have a 2-by-2 contingency table that summarizes the data. Let's go to a specific app, the association between two categorical variables app, to load this data in and to see a graph and to compute some statistics, in particular conditional proportions. So I'm now going to go to the website ArtofStat.com, which is this website here, and then click on Web Apps. I'm going to scroll down a little until I get to a subheading called Association, because this is what we want to explore, the association between two categorical variables, and in particular, 2-by-2 contingency tables. So I'm going to click on that app, and you will see some material coming up. You can actually use preloaded data sets from the textbook, and I'm going to do this in a second, but if you have your own contingency table data, you can enter them here, or you can also upload your own individual observations on two categorical variables. But I'm going to look at the COVID-19 data set that's preloaded from the textbook, and the contingency table you see here, that's exactly the one I showed you before, with 222 patients randomized to remdesivir, 199 to placebo. Now, as always, to compare or to analyze the association, we want to look at the conditional proportions. And that's formed here. I simply computed of all those 222 patients under the remdesivir treatment, what proportion did recover, and we see that 0.797, so roughly 80% recovered when the patient was on remdesivir, and or compare that to the 64.3% of patients recovering under the placebo treatment. Now, if treatment and recovery were independent, in other words, if there were no association, you would expect those proportions to be about the same. But they are not, they are different. Let's describe that difference. We could do this in one of two ways. We could just compute the actual difference of proportion, and that's my first measure, the difference of proportion, or we could take the ratio of those two proportions. Let's do the difference of proportion first. So this is the statistic that I'm going to use for describing the association, the difference of proportions here. And I see it displayed here. All that's been done is we take 0.797, the proportion of those recovering under remdesivir treatment, minus the proportion recovering under the placebo treatment, and 0.797 minus 0.643 gives you 0.154. That's called the difference of proportion. Now, how do we interpret that difference? I'm going to switch over to a homework assignment I have done. And let me give you a second here, where I took a screenshot from the app, and now I pasted it into my homework. And so you should see it now. Let's get this up a little bit. And so here's the screenshot I just showed you before, showing the two tables and a bar chart that shows the proportions recovering on the remdesivir and placebo, with the one recovering slightly higher for remdesivir compared to placebo. We've just found out by taking the difference how much higher. Well, we've got a difference of proportion of 0.154. You might be tempted to interpret that difference as in the box here. The percentage of patients recovering is about 15%, if you want to be precise, say 15.4% higher for those on remdesivir compared to those on placebo. And I'm quoting roughly the rounded percentages here for the two treatments. But that would be misleading. We'll actually find out in 5 minutes, or 2 minutes, that in fact, the percentage of patients recovering is not 15% higher, it's actually 24% higher. So we gotta be a little bit careful when we interpret the difference of proportion. We don't wanna say 15% higher, we wanna say it's 15 percentage points higher. So I'm gonna actually strike that out and put in what's truly should be an interpretation is that the percentage of patients recovering is about 15 percentage points. Percentage points higher for those on remdesivir compared to those on placebo. You add 15 percentage points to 64 to get to roughly 80. So this is the interpretation of the difference of proportion. Another way, as I've mentioned, to compare the two proportions is to take their ratio. Let me go back to the app. And instead of taking the difference between those two, I'll take the ratio. I simply click here for the ratio of proportions, and then 0.797 divided by 0.643 equals 1.24. This is called the ratio of proportions, sometimes also called the relative risk. And what it says is that take 0.643, multiply by 1.24, and you end up with 0.797. When you multiply something by 1.24, that means you're increasing it by 24%. So if you want to have an interpretation in terms of the percent increase, then we look towards the ratio of proportions and say that the proportion on the remdesivir is 24% higher than the proportion on the placebo. So switching back there to my homework, I could then take this, let's see if I can move this up here, and say the percentage of patients recovering is about, not 15, 24% higher for those on remdesivir compared to those on placebo. It takes an increase of 24% to get from 64 to 80%. So those two boxes are the difference between interpreting the difference of proportions and the ratio of proportions. Now, I encourage you to go around and play around with other data sets in the app, and there's many other pre-implemented ones that you can choose from, such as eyewitness testimony and other data sets. And going back to the COVID treatment, later in the course, especially when you focus on the difference of proportions, we'll not just be content with estimating that difference, we'll also be looking towards inference. And so back then, we'll define what a margin of error for that difference is. And in particular, we'll compute inferential, or we will put inference such as finding a 95% confidence interval for that difference. But that is to come, and that's going to happen later in the course. So just summing up, what we learned in this video is we compared or computed the difference of two proportions and contrasted that with the ratio of two proportions. C, we saw how we interpret each other. Both are measures we use for describing the association between two categorical variables. Thank you.